and join in with me. Okay, so difficult to see at the top, but don't worry about it. This is enzymes for GCSE, but, alright, I'm just going to do the basic introduction. Enzymes is the cornerstone, it's the crux of all the stuff you're going to get in this topic, right, in B2. So I need you to understand the basics. Right, I want to start off with some simple points. Okay? Enzymes. Let's start with first. Enzymes are proteins. It's a very classic question. You know there are major types of biological molecules, carbohydrates, fats. Well, enzymes are proteins. Proteins, if we go back a little bit, proteins are made from what chemical? Can anyone tell me?
Amino acids.
Good. Proteins are made from amino acids, long chains of amino acids. Alright? And this means that proteins have a very important structure, and I will come on to that later on. This is going to be all linked to what enzymes are. Right then. So enzymes are proteins. Second point. What do enzymes do?
They break down stuff.
Alright, I like it. Now, that's one of the functions, they break down stuff, and often we think about that all the time when we talk about digestion. But, in general, enzymes control reactions. Better than that, enzymes speed up reactions. Alright? So if we get that, we'll be okay. So, enzymes speed up reactions. Now, that's not beautiful science, because really, they just allow reactions to happen at a lower energy. Alright? And I'm going to go a bit further with that. Alright? They lower the activation energy. Now we're starting to creep into A level here. Alright? And I just want to explain what activation energy is. It's on the board as a keyword, so we said you couldn't find it. Right? When you've got a reaction, let's say, okay, we're baking a cake, alright? If I bake a cake and I get the flour and the eggs and the milk and I put them all together and I mix them round, it doesn't turn into a cake. Oh yeah, there's a cake there. I have to do something to those ingredients to make them react. I put them in an oven. Would you agree with that? And when I take all those things and put them in an oven and get them to react, then we get something new. We get a product. Okay? And that's because I have to put energy into those chemicals to get them to react. Are you with me there so far?
So what if they don't react though?
Well, we've got a rubbish cake. But that energy that you have to put in to make them react is called activation energy. To activate them to react. And what enzymes do is they make them react with less energy. That's a big concept, right? So I hope you grasp that. That's what an enzyme does. It lowers the activation energy. And I'll put a little bit here. The energy needed to start the reaction. Alright? Now, any chemical that does that is called a catalyst. Right? Which is why enzymes are often referred to as a biological catalyst. Alright? So that's another phrase I want you to be aware of. Enzymes are often called biological catalysts because a catalyst speeds up a reaction, and these are biological molecules. So enzymes are biological catalysts that lower the rate of reaction. Now, last little bit, I'm going to try and introduce how enzymes work. Okay? So I'm going to draw what I now refer to, and what you often get, is a circular molecule that looks a bit like a Pac-Man, but it's not. This is a standard diagram you'll get in your textbooks. I want you to explain it to you. This circular molecule is supposed to represent the enzyme. And this very funny bit here, this funny shaped bit, that you might think is the mouth of the Pac-Man isn't. It's a very important part of an enzyme called an active site. Now, the active site is where the reaction happens. It's where I'm going to introduce a word here. It's where the substrate binds to the enzyme. Now, I just talked about all those ingredients. I could have used another word. I could have used the word substrates. Substrates are the things that start the reaction, and then what comes out of the reaction is called products. Substrates at the start, S's, what comes out are products. Now the key is, substrates have very different shapes. Okay? And in this example, I've drawn substrate A and I've tried to draw substrate B. Enzymes are what we call specific. Now that means that they only work on certain substrates. Can you see by what I've drawn that this enzyme will only work on one of these two substrates? When I say work, I mean it'll only speed the reaction up. Which one?
B.
Which one?
B.
B. This enzyme will only work on substrate B because why? Why?
Because it's the shape of the triangle.
It's
the piece.
It's all about shape. And you all said shape, and somebody said it's the same shape. Can I just change that slightly?
It's the puzzle.
It's the exact opposite shape to the active site. Did you get what I mean there?
Yeah.
It's not the same shape. If it was the same shape, it would go in. It's the exact opposite shape, and we call that complementary shape. I wish I could write. And it's complementary shaped substrates that will fit into the active site. And I'll try and show you what happens. So, this is now our active site. I'm drawing it again. But we have now, oh, drop your pens. The substrate has bound to the active site because it's got the right complementary shape. And now the enzyme does its job of lowering the activation energy and making this break down. And therefore what is produced is, well, the enzyme's still there. That's a beautiful thing about an enzyme. Enzymes can be used over and over again. But now the substrate has been broken down into two products. So, if I just come back again, what am I calling this molecule B again? What's that word I've been using?
Complementary shape.
That's, the complementary shape is the shape
The
of it.
enzyme.
What am I calling it as a molecule?
Substrate.
Good.
Substrate.
This is the substrate. And what happens when the substrate is broken down? What do we call it then?
It's a product.
Good, well done. These are the products. Right. I'm going to throw one more phrase out to you, and it's the last thing I want you to grasp, and only get it if you're really thinking higher. This bit here, where the enzyme and the substrate bind, it's a little bit like a key going into a lock. Only certain keys will fit the lock, others won't. Do you see that?
Yeah.
If I try my key into your house door, not going to fit, is it?
No.
Which is a good thing.
Yeah.
This theory of specific complementary shapes is called the lock and key hypothesis. Because how these work is a bit like a lock and a key. Only certain substrates fit into the active sites. Like only certain keys fit into locks. Yes or no?
Yeah.
Right. Enzymes overview. Good.